Hello, this is Paul from Foresight Tech. In this lecture, we do application. We will try to find the area between curves by integrating along x direction. And here the question. And if we have two curves, one curve is on the top, y equals f. We call the top curve yt. Okay, and another is the bottom, y equals gx is the bottom curve, and we call the yb is the bottom, the height we call it. And then the two curves form a region, so we can see the regions for axis go from A, the right point is goes to B. This region has an area. How to find the area is the questions. And we have basic integration method we learned before, right? Cut the area into pieces and then integrate all the pieces together, which means do Riemann sum and then take a limit, which means what? The integration. I mean we need to integrate the area from A to B. How to do? See, we cut each pieces. In this graph I show one piece of the rectangle. So suppose the bottom is x. At x, so we cut one piece, and then extend a little bit. We call the increment is that x, and then we will find the rectangle. And we easily find the area for this small rectangle. How to find? So is the width. The width is delta x. So about the height. How to find the height? So we can see the highest is f, right? Fx. The lowest this point, the height is g, so f minus g, or we say y top minus y bottom. Okay, the distance between two y is the height. We use the height times the width, we get the one piece, and then we integrate all the pieces together, take limits, right? If we make a formula, this is the major result. The area is integration for all the area of rectangles. The rectangle is the height times the width, right? The axis is that axis with times this small area, the small rectangle, and the integrator means add all the rectangle together, take limits. Okay, good. So we have a major result now. Okay, the one I have to mention. So how to use this formula? We need to mention which function minus which function. We should be use the top. See, we should use the top minus the bottom always. Okay, and then we will find the results. I will show you a few examples. Let's look at the first. Look at the first example. Suppose the graph is already here. Okay, it's already showing you. You know the graph, and from this graph is two curves, right? The top is y equals e raised to the x power. The bottom is y equals x times e raised to x squared. Okay, the two type of functions. So we know the top, right? So we know the bottom. Okay, so I say in this form, this region, we can see the region very clear. So we find this top. So it's better I just put this y t. Okay, the top. So this is the bottom, right? So this one I called up here is y bottom b, because we later need to use the top minus the bottom. Okay, and then integrate from x a to b. Where is a? Of course, we can see easily, and this point is the left. So we found at the top, we found at the bottom, we need to find the left and the right. The left is 0, right? Easy to see. So what is the right? The right, we need to project this point. We know this point, that's good. So I know what is this b. So this b should be 1, right? I mean what? We should be integrate the region from 0 to 1. And then we're going to write the formula. So I say the area is here. Okay, the area equals integration from 0 to 1, and then we use the top minus bottom. Remember the formula, okay? The top is e raised to the x. The bottom is x times e raised to x squared, and then dx. We know this is and this one is yt top, right? And this one we know is y bottom. So that's the formula tells us. Now we form the mathematical questions. We form into the formula. The setup is ready. The next step is just easy, going to do calculation. We have a fundamental, right? So far we have a fundamental and the substitution method that we do. And we look at this function, and this is good. This is the difference, right? So the first we can find the antiderivative. However, the second looks a little bit complicated, okay? But we can do substitution, okay, later. So first step, we look at this is ready, so we separate it into two integration. So is this 0 to 1. And the first is ex dx. Minus the second is 0 to 1 integration. X times e raised to x squared dx. Okay, and the first is already. So how about the second? The second we cannot find a single antiderivative formula for this integration function, right? Because this is a complicated function. However, we look at this term. However, look at this is the trouble, right? We can do substitution. Okay, we do this. If we do substitute, it is the substitute. I use u equals x squared. Okay, now it's good. We need to find the x times dx. So how to find the x times dx? We take a du. So we have du equals 2 x times dx from this formula. And in this way, we find the x times dx if you switch the order. And from here, I get what is x times dx, right? X times dx equals 1/2 du. Good. So we look at it. This is the substitution we need. And this is x times dx we have. Okay, one more, don't forget. And we do the limits, right? We have to change the integration limit. Integral limits, how to find? I put it here. We say x equals 0, right? X 0, we need to find the u. X equals 0, u equals u, good. And another is x equals 1. The upper limit, what is u? U also equals 1. See, look at the date, they do not change the limits, right? However, we did the calculation already, so that's good. So now we are confident for the substitution, right? So this one we need for the limits. Okay, good. And we move to another step. See, the first step we already know, right? This is the fundamental. E raised to the x has a antiderivative is the basic formula, right? Which is what? E raised to the x power. And find the difference between 0 and 1, fundamental. The second is substitution, right? Substitution rule. Okay, and then minus, how did you substitute? Okay, the limit is here 0 to 1 still. And then e raised to the x squared power is e raised to the u's power, right? E raised to the u's power. And the x times dx. X times dx is 1/2. Okay, is times 1/2, and then du. Okay, this is do substitution, right? This is the substitution. We have the first one ready. The second one now, 1/2 we can take out, so no problem. 1/2 we can take out, and the e raised to the u's power. Okay, we know the antiderivative, right? So we get this, and this should be equals. The first one I just keep here, okay, 0 to 1, and then minus this time I can find. So 1/2 I just take it out, 1/2, and then the derivative of that is e raised to the u itself, and then we find the distance between 0 to 1. Okay, now just do calculation. So the first the product 1 is e raised to the 1th power minus e raised to the 0. 0's power is 1, right? Minus the second is 1/2. E raised to the 1st power product 1 and minus e raised to the 0's power. Okay, and then simplify. I simplify to get the result as 1/2 e minus 1. Okay, use the exact value. This is the first part. We look at the second example, and here is the second example. So we need to sketch the region. See, have you seen a graph? No, we don't have a graph. Okay, so we have to graph by ourselves, and then we will need to find where is the region, and then use the method we just should to find the area. So the first we look at it one by one. So the first is what? So the first what type of function? So we learned. So this is what? This is a parabola, right? This is a parabola. Okay, good. We know this parabola. We look at the x square should be equals to negative y. So it's open down, right? This parabola is open down. This is also parabola. This is also parabola. And this x square is positive y is open up, and then one open down, one open up, we can form a region. So let's go to draw the region. Okay, so I will going to graph the function first. Okay, graph the function is like this. I draw the graph here. Okay, so I'll get a little bit bigger. This y, this x. So the first one is open down. We look at the top point. The top point means the maximum y is 12, right? So it should be 12 like here. So I put a 12 here. Okay, this is the vertex, and then open down. I just roughly draw the graph. So probably look like this. The top, and then open down. Good. This is y equals 12 minus x squared. The first. This intercept we can find, but we don't need. So I will going to draw the second. The second is open up. Okay. The minimum. So we look at it. See, the minimum. I means the vertex is -6 at y. So -6 probably like here. Okay, like here is 12, right? We know. So here is a -6, and then it's open up. Okay, so we're going to think about it. Okay, it's not so wide. It's like this. We're going to draw the graph, and then so can we see? So this is the bottom is y equals x squared minus 6, and then can we find where is the includes the region? The include the regions is here, right? So we can highlight. Okay, see, and like a candy. And what do we need to do? So we need to find the top. The top is already right, and I put the top is here. So this is a y. So this one is a y t. We already have. So this is one is a y bottom, right? The bottom y b we already have. Good. So where's the integration? So from the left point to the right point. See, we don't know this point, therefore we don't know this point, right? We don't know this intersection point, so we don't know this. So once we find these 2 points, we can make sure what is A. This is A, right? And this is B. Okay, we need to determine this. Now the step we have to figure out what is A, what is B, right? How to find? How to find this intersection point? So we need to resolve the linear to resolve the system, non-linear system. Put these two equations together to resolve, and I solve this to here. Okay, so we go back later. If someone you forget how to draw the graph for the parabola, so which we learned in trigonometry, right? 172. If you forget, Okay, another way is we got to get a graph. So everyone, you have a graph calculator. If you have a graph calculator, use your graph calculator to draw this curve and this curve on one graph. If you draw that, definitely you can find it. Okay, so you can find the graph looks like this. So now we need to find this point. So find this point, all these points, we need to solve. Okay, put these two together is this. Y equals 12 minus x squared. Y equals x squared minus 6. How does all this system? We can eliminate the y, right? It's easy to look at. We can eliminate the y, right? This y equal this, so the right equal this, and then so for x. After you get the x, back substitute, you can get a y. So it means you can find the point. I directly get the results. Okay, I'll skip this step. Get the results. The results is this. One point is here, is negative 3 and 3. Another point is 3 and 3. So this is the results. What does this mean? And that means this is the first point. See, we know this point. So I put the point here is negative 3, 3. Okay, and the right point is here. We also know. So this point is 3 and 3. So now have we determined A? So this is the x negative 3, right? So now we get this is negative 3 and this is 3. So that's good. We determine the integration interval from negative 3 to 3. Now what do we need to do? So it's just use the formula to find the area, right? So what is the formula? I put the formula here. So we have area equals, the formula is this, A to B. A, now we find negative 3. B is 3. And then do what? The top minus the bottom, right? So YT, what is YT? Here. So Y, right, is 12 minus x squared. So this one minus y bottom is x squared minus 6. See, I put this together and then do integration. So we find that this is a yt, right, the top, and this is the bottom. Okay, so now it's good. The left is just do calculation. Do calculation is another big issue, right? See, this is a polynomial power function, so easy to find. So the first step we simplify negative 3 to 3. Simplify this, what do I get? I get 18 minus 2x squared times dx. Okay, and then we look at this is a polynomial. Polynomial is easy to find. This is power, so antiderivative is their power. So what is the antiderivative? Is 18x. Okay, and then minus 2 over 3. So 2 over 3 x raised to the power of 3 with 1 more power, right? And between negative 3 to 3. Okay, so I plug in. So the first plug 3 in is 18 times 3 minus 2 over 3 times 3 raised to the third power. I think this is the first, right? Okay, and then minus the second. Second plug negative 3, so it's 18 times negative 3 minus 2 over 3 negative 3 raised to the power of 3. And then you can use your calculator to calculation. So what I get is the final is 72. Okay, so this is the result. Means this area is 72 unit. Okay, and one more. So look at these questions. How to find the region is the same. Okay, we don't know the graph. What we need to do is find the graph first. We're going to find the graph. So what these functions? This is cosine for x between 0 to pi. Okay, we know 0 to pi is goes down, right? This first I know this is goes down. This is a decrease, right? We say is decrease from the highest point. It's from 1. When x equals 0, this is 1. When x equals pi, this goes down to negative 1. So from 1 to -1. Good. So this we look at means the first we know. How to draw the second? So the second this time cosine is decrease in this interval. So negative cosine is increase. So it's the increase from what? X equals 0 is the lowest point. So they are at the lowest point, which is 0, right? Why? Because 1 minus 1 is 0. So this is increase this time. Is increase from what? X0 is 0. X equals pi, the highest point, which is x cosine pi is -1 minus -1 is 2. See? Okay, so I have the basic information. Now we can draw graph. I draw the graph here. So I draw the graph like this. Okay. Okay, this is higher, this is y, this x, this is O. Look at the first is decrease, right? So if from 1, because later we go to 2, I get this is 1, this is 2. From 1 to -1, so like this is -1. So the first is from 1 goes down, right? Okay, everyone know this. If I say pi is like here, this is pi. The middle is half pi. So remember the function goes down. Okay, and this is -1. This is 1 goes down. We can draw like this. Someone you learned this is very good curve, right? Go to the okay. So what is? So this is a y equals cosine x, the first. Or you can do what? You can use your graph calculator to get the graph. The second I will draw this is from 0 to 2. 0 here. 2 x pi to 2 is like this. Okay, somebody say is this high. Okay, it's from 0 raised up to 2. I just draw like this. Okay, or you can look at your graph calculator. Okay, the highest. Okay, this is the graph. What this is a y equals 1 minus cosine x. Okay, now the graph is okay, but where is the includes the region? The region is from here. We can see clearly, right? Here, this part. What does it mean? This time we have one part and the two part. Okay, so we have. Like somebody say we have this time we have two parts. We have two parts. We need to find the first and then find the second. Like find the first. Okay, what is the top? The top this time is here, right? I mean for the first this is the top. Can we see? So this is the top and this is the bottom. And what the left? 0. What the right? So we need to find this point. The right is here. Okay, what is this point? Is big questions. If we know this point, we know it's integrated from 0 to this point, right? The first point we can find. And also if we know this point, the second part, see this time is the top, this is the bottom. So look at the two sides, the top and yt and the yb switched. Okay, and the major one we need to find this. Why the right is pi, right? So we need to do what? Find this. You know how to find it. You just solve, right? Solve this and this two equations together. So I'm going to put here. We're going to solve y equals cosine x and y equals 1 minus cosine x. And then to find this intersect for x between 0 to pi, we should find a 1 point. Okay, one solution. How to do? Y equals y. Of course, this is what? This is eliminated, right? So you can do eliminate y. After you get x and then back substitute, you can get y. Okay, so I ignore the middle step. I'm going to find the results. What the results I get? The results I get x is pi over 3. y is cosine pi over 60 degree. Okay, cosine 60 degree is 1/2. Y is 1/2. 1 point means what? Okay, means this point we know is pi over 3 and 1/2. Okay, and then what is this point? Okay, A to B, so we know B, right, is pi over 3. So very good. Now we can just do calculation. I'll put the results here. The setup. This is very important. Okay, so we get the graph and then we can set up the equation, right, to solve the first area, to solve the second area, step by step. Okay, so just be patient now. Is the area equal this? So for the first part, okay, it's from 0 to pi over 3, right? 0 to pi over 3. Do integration, and then it is, what is the top? This time the top, don't look at that. Okay, the top is there. So can we see? And this one is a yt, right? Where at the bottom, this one is yb for the first part. So yt, the function is y equals cosine x. So I have it put here, cosine x. Then minus the bottom yb is there, is 1 minus cosine x, and then dx. So I look at this. So we know this time cosine is yt, the top. This is the bottom y. And now we get the first down. And we're going to set up the second area. The second area is the integration, right? From pi over 3 to pi. And then the same. What do we need to do? Find the top. So we have the top. The top is there, right? So this time is yt. This yt is different from the yt, okay? So what the bottom? The bottom this time is there. This is yb. Okay. For the second part, so we're going to yt is 1 minus cosine x. Okay. Yb, the bottom is cosine x minus cosine x, and then dx. So we say this is time, this is yt, the top. This is the bottom. See, both two we change it, the top and the bottom. After we set up, now what we left is just do calculation. Okay, do calculation. I will go quick. So first simplify 0 pi over 3, and there is 2 times cosine x minus 1 dx, right? Simplify it. I'm going to simplify the second. The second should be 1 minus 2 times cosine x, okay, dx. And this is a trig function. Cosine, we know, right? The antiderivative is a sine. So cosine is a sine. Okay, now we directly use the fundamental. The fundamental, the first is this. 2 times sine, right? 2 times sine minus 1, which means minus x. This is the antiderivative from 0 to pi over 3. And then find the second is the same. We're going to, 1 is x. Minus 2, okay, times sine x. From 0, no, sorry, it's not from 0. From pi over 3 to pi. Okay, and they plug everything in. So I plug. The first I plug in so sine 30 degree. You know sine 30 degree, right? So I put it here. Well, the sine 30 is, I put it here. So you need this. Sine pi over 3 sine 60 degree, 60 degree, which means square root of 3 over 2. And then put here 0, put is sine at 0 is what is 0, okay. And then we need this 2. So the first we cancel 2 is square root of 3 minus pi over 3, and then minus 0, plug in 0, just minus 0. This is the first. And then go to the second. The second pi plug in is pi minus 2 sine pi. What is sine pi? Sine pi is 0, right? Okay, I put it here. sine pi equals 0. Okay, all this we need to use in this step. So minus 0, and then plug 60 degree. We know 60 degree is there, right? So we have to minus pi over 3 minus negative, which means a plus, right? So now plus square root of 3. Okay, and keep in mind that so this is a plus because negative times negative. Okay, and simplify, we have the results. I have the results is 2 times square root of 3 minus 2 pi over 3. Okay, you can go to verify. That's these questions. Be patient. The last question. The last question is we still don't know the graph. So what we need to do? We're going to graph. So this time, where the graph? So first, each one. So this time a little bit more. Okay, be patient a little bit more because we have 2 functions. Remember, so the previous is only like a 2 curve, right? This time is 1, 2, 3 or more. So look at what this curve. So this is a parabola. We know so the parabola, and the y positive was open up. This is a parabola. Y positive is the open up. Parabola. What is this? Everyone know this is a straight line. Good. And for x greater than 0, right? And then I will go to graph. I graph it here. I will graph this way. Okay. Greater than 0, so I can do in this. I put the y here. So this is y, this is O, this is x. I will draw the first. This is parabola open up, right? So do you know the relationship between this parabola, this parabola? Then the both parabola go through 0. Okay, means the vertex is at 0, 0. Open up. Which one increases faster? The coefficient, the big one. So this is goes up faster. This is goes a little bit lower. So I can show the left. I ignore. Okay, I only show the right. This goes a little bit slow. And this is the slow one. Slow one is the first up here. So this y equals 1/14 second square. This goes up faster. Okay, I simply say it's like this way. It's okay. So this y equals 2x squared. For the third one, x plus y is a straight line. And the y-intercept is 3, right? Because the 3 is here. This is x-intercept, which means 3 is also. We're going to. It's okay. It's not scared. I just put it here, and then I link them together. Link these 2 together. F1. Okay, and then this is x plus y equals 3. So good. And where is the region formed by 1, 2, 3? Is this part? See? Okay, that's good. But how to find it? This time, look is different. Okay, what the top? We have 2 parts. This is the top. This is also the top. We cannot say it's one top, right? So what do we need to do? Cut into 2 pieces. Okay, so this is special. If we know this point and then cut this into 2 pieces, can you see? Okay, and this is the left area. This is the right area. I mean, we also have 2 parts this time. Still have 2 parts, the left and the right. What we don't know is this cutting point. And to where this we don't know also, right? We need to find. Of course, you know the first. If we say the first you don't know, I also put a question mark here. So if we find this point, this point, this point, 3 intersection point, and then we know what is the integration. It's from the A to B, from this A to this B, right? So now we solve this one by one. So even we know this is 0, why this is 0 origin? So I should do here. The find this point is link this equation and this equation together to solve, right? So we need to solve y equals 2x squared, y equals 1/4 x squared. Okay, resolve this. How to solve? Still eliminate the y, right? So still eliminate the y, and then you get x. X is 0. Okay, that is you get y is 0. So here is 0 0. See, that's why the first I said this is 0 0, right? Okay, now you know this definitely is 0 0 origin. So now we're going to the second. So the second we need to solve this equation and this equation together. What do we need to do? We need to solve this one is y equals 2x squared, and this straight line is x plus y equals 3, and then the same. Okay, you can eliminate the y, right? Eliminate the y, so it's still the same. Eliminate y. You have to resolve x. After you resolve x, x get 1. Okay, x equals 1 back substitute, so we get y equals 2. So it means it's 1 and 2. Okay, I ignore the middle steps. Means what? This point we find is 1 2, right? So 1 2, which means this projection for x is 1. Good. See. So now the first part is integrated from 0 to 1. So how about this point? The same. We need to solve and this equation and the line equation together. Okay, are going to solve. So this parabola y equals 1/4 times x squared. Straight line is x plus y equals 3. Okay, the same. You still can eliminate the y, similar with the second. Okay, eliminate the y, and eliminate the y, you get x equals 2. Okay, I ignore the step. We get x equals 2. Plug into here 2, I get y equals 1, right? Y equals 1. Good. That's the other point. It means the last point is what? The last point is 2 1. So means what? The projected for x is 2. Good. See, the second part integrated from 1 to 2. Okay, and now what left is what we left is just set up the equation to solve, right? So let me get it a little bit clear. Wait a little. Okay, it's good. So we're going to set up the equation now. So what is the area? Part 1 is integrated from 0 to 1. Now very clear. See, I mean everyone, the first part is very important. Okay, so you graph. After you graph, and then you can see the region clearly. You need to get this idea. And what is the top? So we find the top, right? I did not show. Okay, so the top, which means that directly use 2x squared. The top, the bottom is this curve parabola, 1/4 x squared dx. Can we see? And this is yt, top y, bottom y. Okay, good. This is the first setup. So but the second part is here. This is the top, this is the bottom, right? Okay, or you can say I just put the words. So this is the y top. So in the first, this is y bottom. This is the first part. For the second part, for the second part, this is the yt, right? Top. So what is y top? Y top, we need to find the y. So when find the y, we need to change a little bit. I just change this. See, y equals what? We need to solve for y. Okay, y, because yt is the tall, is the height of y. The height of y is negative x plus 3. I use 3 minus x. See, we find the yt. Okay, y bottom is already. So here is y bottom is there. So this is y the bottom for the second part. So I'm gonna set up the second is integral. Integrated from 1 to 2, from 1 to 2, and this I will use the top is there, y 3 minus x, 3 minus x. So pay attention. So these the whole thing is y top. Okay, and then we need to minus the bottom is 1/4 x squared. Okay, so this is y, the bottom y. Okay, and then do integration. Okay, so I will going to do the integration. So what it is, simplify first. Okay, of course we simplify is 7/4 x squared. Okay, so the first and this one is a power function, and so the under divided is their power. What is the power? I put it here. This is the first power divided by 3. 4 times 3 is 12, so it's 7/12 x raised to 1 more power, 3. 0 to 1. Fundamental for the first part, and the plus. Fundamental for the second part. Okay, so that's easy. So 3 is 3x. X is minus 1/2 x squared. This is the power. So x with the third divided by 3. 4 times 3 is going to 12. X raised to the third power. This is the antiderivative. Okay, find difference from 1 to 2. Okay, the last one, just plug everything. I just skip this plug. Okay, so I put complete everything. So plug 1 is 7/12, right? There, and then minus 0. Okay, so did the first. What the second plus? I put the 2 in is 6, right? Minus 2 is 4, so we get 2. Plug 2 in is 8, so I just direct minus 8 divided by 12. This is plug in 2. Then plug in 1, so it's minus. Keep in mind, minus 3 minus is plus. 1 plug in is 1/2. So be careful about this. Okay, be careful about this. This the negative times negative goes to positive. Okay, and then minus negative the same. Okay, so the plus. I mean, so here is not a negative. It's the same. Negative makes it positive. It's 1/5. That's everything. And then simplify. You can use your calculator. We get 3/2. Yeah. Thank you. That's all.